Good afternoon, good morning, good evening, eCognition users, wherever you may be. Welcome to another edition of our Trimble eCognition webinar series, coming to you live today from a cloudy Vorarlberg, Austria, the semi-intellectual headquarters of eCognition at the moment in the days of Corona. And today we have an exciting webinar, I think personally, for you. We're going to be looking at timber cruising with eCognition. I may take the term timber cruising a little far for some of the traditional foresters out there, but what we are doing is looking at extracting various elements of trees, and I'll get right into that in a minute. This is a Power Hour webinar. So for those of you that may not know, we're going to get quite techie quite quickly in this webinar. So we're going to really spend most of the time in the software. We also have a few slides prepped for theory to look at the various algorithms that we'll be demonstrating today. So again, welcome to our webinar. I'm glad that those of you that are live can be here, and we'll jump right into things here. So what are we going to look at today? Like I said, looking at tree crown delineation. We're going to be using some LiDAR data mixed with imagery to do this. We're going to also present some theory, how these different algorithms work that we're going to be demonstrating today. And of course, we're going to be working in the eCognition developer software, showing you how this actually works in practice. We will have time for question and answer, but you can feel free to use the question field of this GoToWebinar at any time to submit a question. We may take field a few questions in between if they fit the moment right. And yeah, so again, welcome. My name is Keith Peterson. I am the Trimble eCognition product manager. I have as my wingman today, Christian Weise. I don't think there's a better mix of people to talk about eCognition out there these days. So you are in luck. We should be able to answer all the questions you have. The rules of the webinar, before we get too far along, you are all in listen-only mode. Yes, that's intentional. But again, you can interact with us via the questions dialog, submit your questions, whatever they might be. There are no stupid questions, only stupid answers, like I enjoy saying. So really feel free to hit us up. We will also field some question and answer after this session. If you have to step out early, or maybe if you're stepping in just now or later in the webinar, do not worry. The webinar is being recorded. We will make it available afterwards. If you registered for the webinar, you will automatically get access to the recording, but we will also make the recording available on eCognition TV. That's our YouTube channel, and you can view it there as often as you like. All right, so let's get started. We're going to be talking again about tree crown delineation using a mix of LiDAR point cloud. So that LiDAR point cloud is in a LAS format. And we also have some 4-band imagery here. So red, green, blue, near infrared. And we want to extract several aspects of these trees. We're going to be looking at getting an approximate ground position where that tree is going to be. We want to extract individual tree crowns as best as possible. And we are also going to be extracting tree height and converting that into a 3D line vector, as you might have seen from some of those nice screenshots that went out with the invitation. And before I dump right into the demonstration, one thing to note is this demonstration, all the data that I will be using today is available in our eCognition community. Yes, the eCognition community is back after several month hiatus. We were revamping it for you. You can get the data packages that are associated with our webinars there. You can also get other great projects and rule sets examples there. Just go to support.ecognition.com. That is a way of entering our community/knowledge base. you will find then a section called library. Within the library, there's then also a subsection called projects and rule sets, or you can simply use the search field and quickly get there. Just start typing in delineation, tree crown, and you will get this result immediately. So again, enjoy the data package. It's a slightly smaller image and data extent that I will be showing here, just for download purposes, but you can get the rule set exactly as we show it today. All right, before we really jump into things, what are we gonna, when we start here, first phase of what we're doing, because we're working with a point cloud, is we'll look at the algorithm details. I call this the point cloud to raster section. When we're analyzing this, we're going to take that initial last data set and we're going to start converting it to a raster data set. So we have this algorithm. Once upon a time, it was called a LiDAR file converter. For those of you using the new software, this name has been changed. It's now called Rasterized Point Cloud. It's a little more appropriate because it is not only valid for LiDAR, but also for any point cloud types out there. You can use the rasterized point cloud algorithm. Obviously, as it says, we're going to create a raster layer from your point cloud, so we can convert this 3D point cloud data into a 2D raster layer, an image layer within eCognition. You can select a number of different point fields to rasterize. So it could be that you want to rasterize your intensity. You can do that. Or here in our case, we're going to be looking at elevation. And you can take then also different aspects of that, first returns, last returns, whether it's the min, max, mode. There are lots of different aspects that you can rasterize within the parameters. Okay. What this does, it will create a temporary raster layer in your project, in that map environment of the project. Of course, you can export these if you want them, all possible here. And it's important to point out that this output layer, if we think about, well, what kind of resolution is it going to be? Because if you're mixing this with imagery, maybe you have 5 meter imagery, but your point cloud is different. Well, what we use here is the output layer resolution will be derived from that map resolution. So, which is again defined during project generation, or if you actually set up a copy map algorithm in eCognition, you can adjust the resolution. So for example, you can downsample if you're using incredibly high resolution UAV data that they may or may not be needed. You can put that and specify the resolution in the map. So we are taking the resolution of that map and using that when defining the resolution of the rasterized point cloud product. Another nifty thing to mention, we introduced this 1 or 2 versions ago within the rasterized point cloud algorithm, is you can use it to rasterize multiple elements of the point cloud at one time. You don't need to use an individual algorithm for each part if it's coming from the same point cloud source. So if I had one point cloud and I wanted to take the maximum and minimum Z values and rasterize those, I could do that in one single algorithm here. And I'll show you how to do that in just a moment within the software. Okay. All right, so let's jump right in. I'm gonna just share a different screen here before we get too far in with the let's see, I just have to grab the other, might have to grab my screen over here. And just figure out how to, here we go, we're back with the presentation. I'm going to grab in the developer at this point. There we go. Sorry for that glitch. So here we go, we're in this project. Like I said, we're going to jump back and forth a little bit between some of the theory and how it works in practice here within eCognition. I have this project. I have multiple layers loaded to it. I can see that here in my view settings dialog. I have my imagery, red, green, blue, near infrared. These are by the default rasterizations of the point cloud that we do automatically when working with a point cloud. I also have here, I'll turn on the point cloud layers as they came to me. I have 2 point cloud layers. This is how this data set was delivered to us. I believe it's from a section of forest in Bavaria. In this case, I was delivered 2 point clouds, one called a DTM and one called a DSM. So my digital terrain model, digital surface model. That's how it was broken down beforehand. That is my input data today. We'll be working primarily with this view, so it helps us visualize a little bit better. The first thing, I'm just skipping over these. These are just in terms of resetting and setting views here within eCognition. But like I said, the first thing we're going to take a look at is rasterizing this point cloud. Expand this out a bit. And I'm choosing to rasterize elements of the DTM and the DSM here, so that's how I've organized these sections of my rule set. Open up this rasterize DTM process here. So this is the rasterize point cloud algorithm as it's being applied in this scenario. First thing to point out, of course, we have to select what point cloud we want to rasterize. Since I have 2 in this project, I have 2 to choose from. I don't need to define a region because I want to rasterize the whole piece here. I'm also not going to use any type of a point condition. Well, that would restrict rasterizing just certain points. I'm going to look at all of them. Here is this rasterizer 1. So I am choosing to rasterize the point field Z coordinate, obviously because it has my elevation values in this. And I am going to select the operation. So example, I could, if I had different values here, these are all the different types of point fields that you can rasterize if they're available in your point cloud. You also have various operations that you can apply. So in this case, I'm selecting to rasterize the minimum Z coordinate value. Again, I'll just show the dropdown. These are the various options that you have here. If you want, you can apply a kernel size while doing this. Maybe apply some type of a smoothing simplification by doing this. And finally, what is the output name of this raster layer I want to create? In this case, I'm calling it DTM processed. Okay. If I were going to rasterize a second element of the DTM point cloud, you can see that I could start filling this section out here, but we're going to be working with just this piece of the point cloud. All right. I then, while I'm showing you here, I also have this set up to work on the DSM point cloud. In this case, it's almost all the same except for from the DSM point cloud, I am also creating a different layer here. So when I output my results, again, I'm taking the Z coordinate, the minimum value, and I'm going to create now a DSM processed raster. Okay. So I'm going to execute this batch here. Like I said, we will create a couple of new image layers within our project, and we can take a look at those and what those look like at the moment. Christian, while these process, have any questions popped up that we may want to answer at the moment?
Hey Keith, currently there's just a question if it's possible to open this project in an older eCognition version. And here I got this question several times. If it's okay, I will answer it here for the whole group. No, because in the current version we're using here specific algorithms which are just available in version 9.5.1. But if you have an older version of eCognition, that means you are not under maintenance, no problem. You can use the eCognition trial version in the newest branch in the newest version to test the rule set and the projects from the eCognition community.
Absolutely. Thank you, Christian, for answering that.
And there's a fantastic question. It pops up immediately. Why we using the minimum operation for the DSM generation? This is a good question. I think that is a mistake on my side. We have to use the maximum operation. Maybe Keith, you can optimize this for the DSM layer. That's the DTM layer.
Yes. Sorry. Yes. Yes.
Thank you very much, Fiona and Niels, for this. Things to improve. And please
there we go.
us.
It should shoot through pretty quickly. The other thing we can demonstrate here is that by changing this, we can simply just overwrite this layer with the new parameter for us. I'll give this just a couple of seconds to run through. There we go. One thing you will notice is that does not really look like a DSM or a DTM layer that I'm used to working with. It's just a bunch of speckly, maybe if anybody remembers the years of rabbit ear televisions. Yeah, it looks like a bit of static in your signal. Let's just take an opportunity to zoom into one of these areas, and it starts to look a little bit better, but you can still see we have lots of areas. If we're here, this -99, that's sort of this no data area of from our point cloud. And that actually gets me back into the presentation. This was just phase one. We're taking our point cloud and we are converting that point cloud information into a raster layer. In the second step, we want to start addressing the gaps in our point cloud and filling those to generate a real DSM DTM layer within eCognition. So we'll get back to our slides, and we can already see the next algorithm is up and listed. We will be using a pixel filter 2D algorithm. This algorithm offers several filter operations within it. You can apply a Gaussian, a mean, a median, a bilateral, or a morphology filter. In our case, we're going to be working with the morphology filter here. And to be more specific, as we'll see in the algorithm itself, there is a mode within morphology to dilate. What does that mean? It comes from our heady days of bioscience, life science operations. eCognition got started. We're going to dilate. We're going to sort of grow this pixel value here, and we can see a demonstration of this in the little graphic here. So by going in, we can grow into these no data areas and start filling those with values. Okay. In addition, you can use this algorithm typically to remove noise from certain image elements. Okay. So I will get back into eCognition now. Like I said, I'm going to be jumping back and forth a bit today. And this is
Keith,
what we're going. Yes, Christian.
I have to interrupt you because we changed the parameter to the maximum, and the output layer name is also changed. You see, we have now the set coordinate max, and that means you can rename the layer or just test it, rename it to processed.
Overwrite here. DSM.
Processed.
Thank you for catching that, Christian. I would have walked into that one.
Yeah, and then we run into trouble that nothing is working, and that's
DSM process. That's when we want to.
Sorry for it.
No worries. Just shows you can make these edits quickly and on the fly within the software. We'll just let this run over here. And then we're going to get into this fill gaps in the elevation layer. So as you can see, a lot of gaps in our just our purely rasterized layers at the moment, and we want to fill these. The first step we're going to take in filling these is applying this 2D filter with this morphology setting. So I'll get in here. We can open up this algorithm. Again, it's called Pixel Filter 2D. You can see this is an OpenCV prototype within eCognition, but it's working quite well. We're confident to use it today. You have various filters that you can apply. I am going to be using this morphology filter like I mentioned. You can select the input layer as well as the output here. So in this case, I'm taking this DTM processed as an input, and I'm just going to overwrite it again with the same name. And you have these various operations that you can apply. So you can see you can erode, you can open, you can close. We are going to, again, be using this dilate. So we want to start growing into these no data areas. And I'm going to run this in 10 iterations. So the number of iterations will govern the amount of growing. I believe if I remember correctly here, Christian, please correct me if I'm wrong, is that by setting an iteration of 10, we will grow essentially by each iteration is looking at 1 pixel distance.
Correct.
Very good. So I will run this, and we'll take a look at the output in just a minute. All right, so I've just played with some of the equalization settings here. I'm looking at a false color rainbow for this DTM processed, and we can zoom back into an area, and I can see here that these blue areas are still no data values, and we have in the red areas a pixel value. If I hover over that, you can see the elevation value 680.42. So we have run this 2D filter here, but we haven't grown into all our gaps. So we still need to do some gap filling, and that's what's going to be done in the second portion of this. But first, I'm going to create image objects. To do this, I'm going to use a simple multi-threshold segmentation. I can do this because I know the value of my no data values, right? We define those, and if anybody caught on at the start, we saved those into a variable called no data value. We said that's going to be equal to -99. Why save it in a variable? Well, it allows me as a user, if I have a different value, I can just enter it into that variable, and since we use that in multiple algorithms, I don't have to essentially change the hard coding of each algorithm. I just update the variable, and the rest is automated from there. Okay. So we're going to be running this on the DTM processed. We're going to put things into unclassified or into a class called temporary. Right. So we will run that, and then I will show the view, and then that will get us back to our theory slides in the presentation, because the second part of this is now we actually use the fill value algorithm within eCognition. And why the logic behind this, I will why we're doing this in 2 steps with 2 different algorithms, I will clarify that in just a moment. Okay, so now I have 2 classes here. I have temporary, which stores that's everything that has a real elevation value, and then I have unclassified. So the unclassified class is for all these holes in the DSM at the moment. All right, jump back in here, and blunk, blunk, blunk. We'll get to the last step in our gap filling, or in this point cloud to raster section, is now this fill pixel values. So what this does, well, we will fill regions in our raster layers with values from another pixel. Why didn't I do this right off? Well, because this algorithm is processing intensive, and if you have lots and lots of holes, it will run longer. So I first decided to sort of eliminate some of those holes by running the pixel filter 2D. So there were less holes to consider with the fill pixel values algorithm. All right. So what this algorithm allows us to do is to fill those holes based on interpolation from neighbor object pixels. Okay. It works only on temporary image layers, but these can be copied using a layer arithmetic algorithm. And what we're going to be doing here today is looking at these orange areas. So you can see in this screenshot the orange areas again are the areas that have values that we want to fill. Again, these unclassified areas here. And you can do this in several ways. We have different methods of running this. First, there is the so-called IDW. This is the inverse distance weighting method. This is slower, but more precise. Alternatively, you can also use the LIN here. This is a linear method. It's faster, but let's say less precise than the IDW. And we can see why that is in this illustration here. If I were to run an IDW, I would, and I wanted to fill this blue pixel here, I would be starting to compute that fill value by considering not only the gray pixels or the gray squares here, but also the orange squares. All right, so considering many more values for applying that fill. In a linear operator, if we use that linear operator here, we would only be considering those linear relationships to fill the value. So less computing would be going on. So that's what would explain, say, the speed of this. All right. Again, we'll jump back into the software here, open up this algorithm, and take a look. All right. So again, I've defined my input layer, my DTM processed. The class filter is temporary, so that's where my values are. And the calculation mode, we're choosing to run this inverse distance weighting, and we're choosing this distance, this ID distance weight of 2. We're going to, important here is the level, define your level here in the domain, as well as what class you want to fill. So in our case, we're going to be filling pixels in the unclassified class here. All right. And while that runs, I will just hop back in. I wanted to just mention that you can do all this again. Any operations here we can do in the free trial version of the software. We're not exporting any products. So all of these operations here are available within the free trial. Okay. While that runs, we'll just say the next step we're going to be looking at is then a raster to vector. What we're going to be doing is moving from our raster values into image objects into vector formats. Okay. So preview of what's to come. Like I said, we're using that IDW. It takes a little longer to run here, and a very similar operation will be applied to the DSM. I'll show you that as soon as we're done processing here. Christian, any questions from the audience at the moment? It looks like the little question light is flashing on my end of things.
That's very specific questions. If there are also some other algorithms available to fill the, for instance, to fill the gaps like quicking. Here I mentioned already to the people that we have just the IDV and the linear interpolation, but we will check other algorithms, of course, and maybe we can promote here the wish list in our eCognition community, so that you as a customer can also here insert your IDs, which options of existing algorithms or maybe interesting new algorithms should be available in our software, so that we understand your needs here and can improve the software step by step. Also, such IDs to have here other filling options available in the software. But that's currently everything, Keith. There's no further questions at the moment.
Great. Well, this continues to run. I will just jump ahead a bit, and then we'll come back and execute the essentially the same process for the DSM layer. We've set it up the same way. We run. Speak of the devil. Here we go. It's completed. And with the final thing I do is I actually then delete my image object level. Why do I do that? Well, I've used those image objects have already served their purpose. I've used it then to create this DTM process. So again, we're looking at this false color rainbow. That's why it's a little abstract here. But in comparison to how we started with that, say, fuzzy TV look, now we're really getting to what we're used to looking at in a DTM. Okay. And if we just take that one step further and compare here to our DSM, which has not yet been touched, we can really start to see the differences. Okay, so within the fill DSM layer, again, taking the same approach, we'll first be applying this pixel filter 2D process, and then following that up with the fill pixel value. The only real difference that you'll notice if you take this rule set off our community page is that in this morphology, instead of running an iteration of 10, we're choosing an iteration of 5. That's because we wanted to have a little bit more accuracy in our DSM layer. So instead of saying, if we look at our resolution, I believe it's 10 centimeter resolution in this data. So instead of having essentially a 1 meter DSM, we're going to have a half meter, sort of simulating half meter DSM by running it in the iteration of 5. Okay. So we'll let that run. And while that goes through, we'll jump back into the presentation and pick up on the next step here, where we're going to start looking at taking these raster values and converting them to vector. Okay. So once we have these elevation products done, after I create my DSM and DTM products within eCognition, the next step that we have is just creating an nDSM, very simple with the create nDSM algorithm. And from here, we're going to then perform a watershed segmentation. Okay. Now, just for reference, these blue objects here, those are going to be the objects. These are elevated objects. We're going to run a classification and just classify in general elevated objects. And then we would apply this watershed segmentation purely to the elevated objects. Why are we running a watershed segmentation? Well, we're going to apply this segmentation because we're going to try and start to form individual tree crowns. Okay. So we're going to perform this just on this particular region. The way the watershed segmentation works, if you're really looking for details, you're in luck, because our deconstructed video of the month, you could say, is watershed segmentation. So we have a great video series on eCognition TV where we take an in-depth look at individual algorithms, and the algorithm that we just covered was Watershed. I think it's about 15-minute video or so, but really worth viewing to get the full understanding of this algorithm. I'll give you the quick version here. What we're going to consider here in the watershed algorithm is you use local intensity minima, or you can invert the algorithm and use the maxima values, like we will here today. And these will be considered as seed objects. And we will grow these objects into, say, rising intensity levels into the neighborhood until they touch other objects, okay? So as you can see here in this second screenshot, they grow and grow and grow. And then when they start to bump into the next object, they stop growing. If you sort of flip this, the perspective on this, you can see here in this graphic what's going on. So we're starting here. This is looking at it from the local minima perspective, is that we're, say, growing out from the seed object, and we're growing, and this one is growing at the same time, and where they hit each other, that's where the border between these two objects is, okay? It's very useful running on elevation data, but not only elevation data. You can also look at data maybe where you have a strong contrast in light and dark, say in one of your bands. Okay. So how does this work in eCognition? We'll jump back in. My DSM layer has been created. Looks pretty nice here. We'll fold that up. And the next step was then to just simply create the nDSM. For those of you that may not be familiar, the algorithm is called nDSM layer calculation. All I have to do is simply select the DSM and DTM as input, and eCognition will calculate this nDSM, or normalized digital surface model. Okay. And execute this for you, and the view will update automatically, and you can see the value of this layer. Again, we're thinking down the road, we want to extract these tree objects, all right? Zoom into this so we can get a sense of what we're looking at, all right? Looks very nice here. Again, using this false color rainbow visualization method here. Okay, so our filling is done. We've created our elevation layers. We're ready to continue with this analysis. Like I said, before I apply that watershed segmentation, I'm just simply going to distinguish between elevated and non-elevated objects. I'm using a multi-threshold segmentation algorithm to do this again. You'll say, well, what values are you using? Again, these are going to be stored in variables. So if we look here in our variable, the minimum value is 1. So we're saying anything above 1 meter in height, we will consider an elevated object, okay? The second piece here is this minimum mapping unit. I'm not interested in anything, an object less than 500 pixels in size. This is up to you as a user whether you want to set this minimum mapping unit or not. So while this chunk runs, Christian, if any more questions come in that that we can answer during the processing break here.
First, this is not a question, this is a wish. If you later can zoom in a little bit more, that the people see the outlines a little bit better of objects, it would be quite nice. There was a specific question for it. And a general question pops up, if will be the recording available for all the customers after the webinar?
Yes and yes. So here I can zoom in. Right now we haven't yet generated the outlines of, say, the individual crowns, but you can start seeing the outlines for elevated objects here. If I then choose to turn on, say, my imagery in the background, maybe it becomes a little more easier to understand some of this. So you can see we're getting nice outlines around these tree objects here. And yes, the webinar is being recorded, and it will be available not only to people that registered for the webinar, but also in our YouTube channel, eCognition TV. Just give us maybe 1 or 2 days to get it uploaded for you. Okay, so we'll jump back into this this view setting pane here. And the nDSM we want to visualize here. So for those of you more used to looking at your elevation data, say on the the grayscale, this is what we have here. Okay, nice outlines for the elevated objects. And the next step here is to, again, a few steps before we get to that watershed, is we may have some objects. There is potential if most of this subset is in a forested area with little non-forested elevated objects there, such as buildings or stuff, but it could be. So if you want to eliminate those from the analysis, this is where some of the, we can start playing on values from the imagery here. So I'm going to calculate an NDVI layer, and it's simply going to use this index layer calculation algorithm. One of the indices that you can calculate is the NDVI here. Provide my input, and I will run that layer. And again, using the multi-threshold segmentation algorithm here to then differentiate between, say, elevated vegetation and other elevated objects. So I'm essentially going to take here any elevated object with an NDVI greater than negative 0.2 will be put into a class called trees. We can see from here. Okay. And we will just run this packet here and get those tree objects ready for the watershed segmentation. So we're just simply removing some of the objects that will flow into the watershed segmentation. We want to focus that watershed segmentation purely on objects that are trees. Okay. And you'll note, it seems like we may have some users with older versions of eCognition out there. No worries, this index layer calculation algorithm, that's another one of the more recent algorithms. You can also use layer arithmetics to create your NDVI layer. The index layer calculation will save you time for these common indices. And I guess one other thing to mention while this completes its running is once we run that classification or the segmentation classification with the multi-threshold, is that we also do some loops. We're kind of merging and getting rid of some of the smaller objects here using relative border and assign class. So let's take a look at these objects. These are my tree objects in this case. We'll zoom out a little bit here. Things are still looking good with the nDSM in the background, but what you can see, there were some structures here, so good thing we did use this NDVI. We eliminated these structures from the class elevated object. Okay. So I'm going to zoom in a bit here so we can start to see how the watershed segmentation will work and start secluding these objects. And you can see that we're going to be running this watershed segmentation here. We're going to apply the watershed segmentation only to the class trees. So again, that's why we reduce this here. And we're going to be using the nDSM layer as an input here. And we are going to be running this again uses this seed criterion here. It's called this overflow pixel area. Here we're using a threshold of 5. That means that if there is an object, if we create an object that is say 5 pixels or smaller, that we will essentially swallow, that object will be swallowed by one of the neighboring objects here. Okay. So let's take a look at this. We'll run it. It may take a few moments to run here in the background. And if there are any questions that are coming up, Christian, please chime in and we can answer those now.
Yeah, there was exactly a question comes in if it's possible to classify different species after the watershed segmentation. And I will answer this directly. Yes, of course. Here with the watershed segmentation, you get the outlines. You separate the tree area and the different trees or single tree objects. And then you can use the spectral signature of each tree object to distinguish the trees in different species, depending on your spectral resolution of the image data. Here we have red, green, blue, near bands available. I'm not a forester. I'm not so sure if 4 bands are enough with the elevation information to classify different tree species. I think so, but I don't know in which detail this is possible. Keith, I don't know if you have here some experiences. I think it should be possible, but I don't know exactly.
I think you can start getting into, say, a broad, so some of the broad families. So if you can distinguish between, say, deciduous and coniferous trees using 4-band data. Going beyond that, it might be a seasonal type of analysis that needs to go on. So obviously early spring, beech trees, very radiant in comparison to other species. If you happen to have acquisitions from that time of the year, then you can start getting into more of the specific species analysis going on there. To take it down further, to say get the difference between a maple, oak, things like that. There's research that's been applied. You might need say a richer spectral signature within your data set, or potentially hyperspectral data. You can take a look at a blog article that we have. So go to the eCognition blog. I'll pop up the URL later. There is we did cover a scientific paper done by the University of Salzburg on this topic. So you can feel free to read that.
Here in the question window, many answers pop up. It's really fantastic. And here I got some recommendation that 4 bands are good enough to separate 4 to 5 different coniferous and deciduous trees. That's quite interesting. And some people did it also with GUI, but a general recommendation here is also available to have multi-date imagery available to doing this job. That means what you mentioned already, spectral resolution and temporal resolution is here also a key factor to classify tree species. But this is not the job of today. But this is possible, of course, with eCognition.
Yes, great. So now you can see that we've generated these single tree objects. Obviously, in some cases, it may have worked for the crowns may be looking better than others, but in general, it worked very well here. This environment, as you just want to point out, is say a coniferous forest, so it's easier to distinguish these crowns than say a more complex deciduous forest, where you can get say almost multiple crown hits for a single tree, depending on how that tree is growing. But it's a very good indicator here. Okay, so let's step back into that PowerPoint presentation, and yes, Christian, another question.
Sorry, there's a very specific question. Can you please zoom in to the watershed segmentation and visualize just the DSM model?
Sure, we will in just a minute. Yep. So the next step we're going to take is we've sort of got these nice tree crown representations through the Watershed segmentation, but we want to then start getting this into vector data. So we're going to start converting our image objects into vector objects. Right? You can use the convert image objects to vector objects algorithm. Name is self-explanatory in this case. And we convert these image objects into 2 or 3D polygons, lines, or our point vectors. Okay, and we'll jump back in, and we will zoom in here. We'll turn off, maybe just turn on our outlines like this, and we can go in and start getting a closer look here. So we can see here, this would be, say, this local maxima that we started growing out from here, and this regard here was the local maxima from our elevation data going out here as well. Okay, that's what we're looking at. In the next step, we're going to generate these vectors. So the first thing we want to do is run these on the tree centers. We're just going to be using the center of gravity method here to place a point in that tree center. I can make it a little larger for us here, and we can see it. So there we have now a vector point available. And the next thing we want to do is we're going to, instead of using, say, the tree crown as it comes from this watershed segmentation, we're going to create more of an abstract tree crown. And for this, we're also going to be using the convert algorithm, but we're going to be using it in combination with our vector buffering and shrinking algorithm. And the real interesting piece here, so if anybody, again, it encourages you to download this rule set from the community, because Christian included some real gems in it for us. And one of them is this how we're going to create these buffers. Each buffer is going to be unique. It's going to be based on the area of that individual object. So we're using a feature to define the buffering distance. Again, that is going to give us then a unique buffer for each crown here. And we'll take a look at that in just a minute. Let this run through. So again, we're creating a vector of the from the watershed segmentation, and then we're applying this here. So we can see if I zoom, let me make these a little larger here. Yeah, make our points a little larger. So now you can see here, if we zoom in again, this obviously this vector object differs in size from this one, and that's based on the area of this initial underlying object from the watershed segmentation. And the final vectorizing step here, what we are going to do is we are now going to create a vector line. So we're going to essentially approximate that, say, the trunk of the tree. And as you can see, we're again using some variables here to store the X center, the Y center. So essentially the position, we're also going to be calculating, approximating the position of the tree on the ground here. And then we're also going to be taking the Z min and max values to apply it in creating this line, this vector line. We won't really see them here in this 2D view, but that is why we can also look at our vector features and our point cloud features here in 3D. So I'm simply turning on the point cloud. I can come up here and use this 3D subset selection tool, and we'll find sort of a funky area to look at here. Draw sort of a viewing rectangle around this. Take this area here, and we can start to look at these different objects in 3D and see the tree heights and crowns. As you can see, these are 3D objects, that the heights of the crowns also differ here as well. And I'm just going to turn off the image objects here. Stay more within the point cloud. Take a look at the DSM here, and can start to make a little bit more sense to us here as we pan around. So you can see we're also getting some pretty small trees in here. If I knock down the point size, it will probably become easier to see this tree trunk location point here. And that's the trunk line. If we look at it, it's called the tree center here. So you can see this, these points right here. Another nice feature of these points is we are dropping them on the elevation of the DTM. So they'll be sort of floating on the surface of that DTM layer. So that's also really valuable information to have in this file. Of course, all of these vector files, although we're not showing it here today, you can export these purely the same way you would export any vector from eCognition. And then you would have all this, including the attribute information on tree height, crown diameters and sizes. Those are all attributes that can be exported with these vector files. Okay. All right. So I think I jumped a few slides in the presentation here. We skipped right over the vector slides, but I think we covered it pretty well here in the demonstration. So again, using this buffering function, really great thing is we can set that offset distance based on a feature. That's what we've done here. And then we're creating these 3D files, not only for points, but for lines and polygons as well. And again, we can use those features and attach all sorts of attributes to that for the final export. Okay. Before we jump into field a few questions, I just want to say stay tuned. Our next webinar, the date is still to be determined, but for those of you that have been asking, when is the next version of eCognition coming? It's coming soon. eCognition 10 is coming. It's going to be a really great release, and that will be the topic of our next webinar. Again, date we will announce shortly for that. I mentioned a couple websites today. First, the eCognition community. It's back. You can join today, it's free. Go to support.ecognition.com, and you'll get into the knowledge base and the community where you can find, again, all the demonstration material. From here, you'll have access to all sorts of other rule sets as well. Webinar will be eventually hosted on eCognition TV. Here's that URL for that as well. And then I also mentioned the eCognition blog. So if you want to read through that scientific paper on a specific species classification, you can go there. I believe it's organized under forestry applications, and you can start to filter and find it there in the blog. If 3 URLs are too much to remember, then just remember ecognition.com. You can link to all of these sites from our website directly. And that being said, questions and answers, we can jump right into those, Christian.
Fantastic. The first question is if it's possible also to extract the trunk diameter. And here my recommendation is yes, it's possible to do this with eCognition, but not with airborne LiDAR data. Here it's better to use terrestrial scanned LiDAR data. We have here some experiences, and it works also quite well in general.
Yep. It would require just having enough points coming from the trunk.
Yes.
And my experiences with aerial LiDAR, say if you're trying to extract diameter, breast height, or something like that, you typically don't get the number of returns needed to run that calculation from aerial LiDAR.
I had also several questions about the accuracy, how accurate the estimated measurements are, about the crown diameter, elevation, and things like that. And I answered sometimes the question with, it is really hard to measure this because it's just a statistic. Please take a look to the demonstration data. and check the approach, the rule set with your own data, or make your own measurements with the small project what we provided, so that you can get your own data and trust them, and to see how accurate we are. Please use the question dialog here of the GoToWebinar and ask additional questions. Now is the time to do this.
Yeah, we're approaching our hour here as we speak, but we can stay on for a few more questions if you can get them into us. We'd be happy. And if a question comes up at post webinar, or if you are going into, you download the demonstration data pack and you do run into questions later on about specific algorithms or something, you can always ask your question, contact us. Well, first of all, you can always use the community to ask the question directly within the community, and that's a great piece, but you can also contact our support folks at support@ecognition.com, and they can also assist you.
Another question pops up now. That's fantastic. Is the rule set available for download? Keith mentioned this already. Inside the eCognition community, you can find the demonstration project, and of course, the project contains also the rule set. And to do this, you can easily find it by community.ecognition.com and search for tree delineation, and you will find the example project. Here we have now several questions if upscaling processing on large areas are possible also in batch mode. Keith?
This rule set can be completely automated using eCognition server. We haven't done any type of manual operations here, so you can use this on large data sets. Yes.
Fantastic. Then here was the question how it is assigned the height of the cron cycles. Keith, I'm not so sure which height we used for the cron cycles. Each cron cycle has a different height. Maybe
might have been maybe the mean height.
I think it was the mean height. You can define it. The answer here, you can find it directly in the algorithm, which height has to be used for the cron cycle.
So because some questions have been coming up about the eCognition community, this is when you go to that support.ecognition.com, this is what you'll see. You'll be in the knowledge base, and you simply just have to scroll down. Again, it was going into library. You'll be able to find all sorts of projects here, but you can, of course, just use the search, start typing tree crown, and you see tree crown delineation will pop up, and you will find a brief description of this, but you can also download, just hit download example project, and you will get that package there. It already looks like we have some thumbs up on this, so thank you for that. You can also leave comments anywhere in the community. Feel free to let us know how it worked, if you have questions or anything like that. So Christian, before we sign off for today, did any more questions come in?
There's just again a question with the large scale processing, and maybe you can promote here also a webinar about the eCognition server, which is also available inside the eCognition community. You can search for eCognition server and you will find a webinar to learn to use the eCognition server with such a rule set what Keith presented today.
Mm-hmm. Absolutely. There are also links to some more of our popular webinars right within the community, or again, go to eCognition TV and you'll see all the webinars we've done. We've also done some on batch processing with eCognition server.
Here also just some general eCognition question pops up here. Please use the eCognition community to ask your questions so that we can help you inside this environment.
Mm-hmm. Yes. Okay, well, if that is all the questions we have, then I would just like to thank you for your time, and we will see you again in the next eCognition webinar in November. That's when we're hoping to do at some point our Welcome to eCognition 10 webinar. Lots of cool stuff going on in the upcoming version of eCognition that you can learn about. I highly recommend it for new users as well as advanced users, because we are doing a lot in this next version. And yeah, thank you again for attending today. You will find the session on eCognition TV in maybe a few days. Just give us a bit of time. And thank you, and we'll talk to you soon. Have a nice day. Bye.